So we'll have a quick demo by 3 NGOs today: Glific, Benefit and Samanvay Foundation. Each demo would last approximately 8 to 10 minutes, and post that we can take questions from others. So I think we have Gautam and Adira from Benefit. So if you'd like to share your screen, please go ahead.
Hi, I will share my screen. Hope it's visible now. Is my screen visible?
Yes, Adira, we can see.
Hi everyone, I'm Adira from Benefit. I have Mr. Gautam Raj joining me today. So we are here to share about the progress so far on our AI mentor chatbot across like last couple of months. Just before that, revisiting on what Benefit does. We work on transforming youth apathy into agency and skills through consistent hyperlocal change-making actions. We aim to build a movement of 10 million first mile change makers, whom we also call as soul ninjas, by the year of 2030, focusing on climate and civic leadership. So far, we have around 11.6 lakh soul ninjas and 10 lakh plus crowdsourced data. Most of our interventions and programs revolve around three different slabs: learn, connect, and lead. And mentorship plays a very important role in all these slabs. Why AI mentor? So far in our existing system, we have an AI-powered chatbot on the Solve Ninja platform, which collects all the mentorship requests and store it in the backend. So there is a manual manager, like human manager, who would track these requests manually, and within 1 or 2 days, they would assign it to respective mentors according to their skill, expertise, and experience. But with growing demand for mentorship, we need to build a 24/7 AI mentoring companion on the top of our platform. This would unlock ninjas instantly without depending on a human mentor. Also, their intent to action is not locked. The shift in approach. So, during our initial days in the cohort, we had decided on a very simple design, like where we would use one of our recent actions data as a knowledge base, provide it to LLM, and then fine tune the responses against each. But through the rapid prototyping, what we have identified is that not all these actions were very specific, and therefore the LLM responses were overwhelming for users. Users got the information required, but it did not have enough specificity. So one of our very primary goal to eliminate friction in the action taking journey was not met. So we decided not to consider all the actions, only the suitable ones. How did we shift? We shifted from this librarian approach where we show all the information to a chef approach where we only share specific actionable step-by-step solutions through the system. We used AI for the same. We used AI to classify these actions, 47K actions, to identify recipe-ready ones. In the first stage, we identified about 16K actions which had enough context, like on what the action was and on how the solutions were implemented. But even there, we identified for a zero friction recipe, there were many gaps. For example, if a ninja recorded an action on water audit, the context on where this audit happened and how did the audit happen and other details were missing. Even in the second step, we used AI to create these golden standards, nothing but the golden truths to which we could compare. We used AI to pull in all the details from our internal community, and along with the external best practices, we curated a list of 500 valid standards, along with providing relevant context against each of these actions. We use it as the golden truth. This is how the data evolved. Initially, we just feeded the entire actions data to the LLM. At the next step, we also identified the gap using AI. And at the third phase, we also included enough context to the AI so that very specific responses are provided. These are some of the examples, screenshots from our prototype, where if you see this third image, like instead of write a letter to the authority for a portal issue, the LLM has provided all the details and the format of the letter with all the details that should be included while writing the letter. So it provides the enough context and very specific output. So far our AI response logic is very simple and straightforward. We map the input from the user against these 500 golden truth and then frame the raw data and provide back the responses. We have not used any fine tuning so far. Instead, use these golden standards and context to find the instant match. Recently, by the guidance from the mentors, we have also started logging the responses from the test users. So here, what we do is log the responses and then map it against the golden standards for evaluation. This would help us, like in the future, to improve the prompts and the knowledge base. So, a couple of takeaways which are already shared, but reiterating, one was the focus from data volume to delivering very specific actionable solutions back to the user. And the second was using the AI to clean classify actions instead of depending on a human resource to go through all these 47K and identify the gaps. And third one, the continuous evaluation and improvement on the captured inputs. So on our evaluation metric, a couple of goals we had initially noted was to eliminate the response time for the user. So using this AI, we are able to eliminate this 2-day waiting gap to 0. Along with this, we also want to, in the future, make sure that this faster feedback is also driving enough engagement. So we would like compare this AI responses with the ordinary pattern, and we want this to be increased, the engagement to be increased by at least 20%. So the next goal was to optimize the mentor capacity at least by like 100%. So here as well, we need to make sure that the quality of action is not compromised, even when there is an AI motivated response. The sooner actionables next steps, couple of analysis, one on the response pattern. Like there are like failures in terms of the response from AI. We need to analyze these failure modes and also flag edge cases that would require human escalation. The next one is on the tone and quality of the responses, where the AI should not be biased or inappropriate. We would benchmark it against the golden standards which we have created. We also feel there would be multiple iterations required on the prompts. This right now we are on the version 4. So this above analysis along with the refinement would help us to expand the learnings and golden truth going forward, which will provide better responses. Yeah, thank you.
Thank you so much, Adra, for the walkthrough. Any questions from anyone?
Audible?
Yes, Hamish, we can hear you.
So I just wanted to know about the stack for handling the conversations. So it is a Versal app, and what is the overall tech stack which you have for the chat conversation in general?
Yeah. So Himesh, with the pilot, so we haven't incorporated into our actual system yet. So currently we are working with the controlled group. So ideally this will be hosted on our Frappy systems, which is what actually powering up, and then we are just using OpenAI as for the AI. So this one is just purely quick, robust prototype that we have built for.
Okay, so you will be using the chat SDK of OpenAI
Yes.
integrated into your app.
Yes.
Thanks.
How did you provide the knowledge base? Like I'm assuming all the previous knowledge base of the actions and the issues would be in a knowledge base, which would be long in size. So how did you manage? Like what do you use for that?
Yeah.
The
So
RAG. Yeah.
I mean, it's a very straightforward implementation we did. Credits to our mentors. So basically, what we did was we had 47K actions.
Okay.
So basically, these are 47K rows, multiple columns. We just
Okay.
took this and put it into OpenAI's vector store. That's it. And then we have an assistant, and through that assistant, it's currently working upon. That's the first version. But then we actually cleaned up few things using AI itself, and then that 500 golden standards. So to answer your question, we are actually directly ingesting it into the vector store in the OpenAI dashboard.
Got it.
Any other questions? Okay, I think we can. Okay, there's one question from Gokul.
Sorry, just one quick question. Wanted to check, considering the number of possibilities are higher, number of problem statements are higher, and the categories are also a lot. Are you able to manage that broadly through a prompt management system itself, or do you envision a workflow of sorts that needs to come in for, let's say, specialized request, either from a domain perspective or specialized request from an action perspective?
Okay. So Gokul, at this point, we are not seeing much changes because it's a very controlled group, and then we are not seeing any exceptional cases coming up. But one thing with that we are very clear, we wanted to take an approach where it is actually slightly, which is more principle oriented, rather than it is specific to an issue or it is specific to a specialization, etc. So we are yet to get there, to be honest. But so this is something that we wanted to anyway experiment with.
Got it. Sounds great. And were there any, let's say, prompt changes that sort of increased the correctedness or something like that? Any best practices that worked for you?
Yes. I think we have 4 versions of the prompt so far. I can share that with you later. We see a direct correlation between the prompt and how the knowledge base is structured. The last one, what Athira has shared, the last one is more specific, has multiple columns and have specific examples. So it's not giving literal output; it is using the contextual principles and then using it. So there's a direct correlation between these two. So better the knowledge base, better the prompts, specific the response.
Perfect. Sounds good. Also love the email generation idea, just to be able to copy paste and use it. I think that was great. Thank you so much.
Thanks, Open.
Okay, so if there are no further questions, thank you so much, Gautam and Adira. We can start with Glific's presentation by Amisha and Akansha. Yes.
Is the screen visible?
Yeah. Yes.
Hi everyone. Thanks, Aishwarya. So we have built an AI assistant on the Glific platform. So actually the problem was new users used to struggle with Glific features, though we have a documentation, but the documentation is kind of long, and it has a lot. I mean, since Glific provides a lot of features, so it was hard for a user to understand the doc and features fully there. And also in the documentation, like they can't cross question. There is no context or anything. They just need to go through the documentation, and we otherwise they need to come to Discord for support, where where we our support team will give them the answer, but it kind of take a while to answer. Uh, so we wanted to build an AI platform where user can ask their question without even waiting for someone to answer for them. Uh, yeah. Second, yeah. So the solution we have come up with, we've embedded a chatbot inside Glyphic to answer all the user queries, like features, flow, setup, what all the best practices they can follow. And since we have a good amount of data in Discord, we also integrated our Discord data with that chatbot and our Glyphic documentation. And the chatbot is also context aware, like which page is user is in right now, so they can ask all the question around the page and all these things. Mm, yeah. So for that we chose Diffie. So Diffie uh, is so we are using Diffie to do all these things for us, like to call the AI and call our talk with our APIs and everything. So why we chose Diffie? So we didn't make an in-house rag. Diffie gives us that retrieval argument generation, so we don't need to build our own. And also it gives the knowledge base management for non-engineers as well. The platform is kind of easy to use. You just need to upload the knowledge base and create a flow there. And from Glyphic, we just need to trigger that flow, the flow that we are using in Diffie. And it also has built-in conversation history and feedback it captures. So it can remember the conversations. It's basically like the chat GPT. You can talk and it can answer to your previous questions as well. And this also gives the support for different LLM providers like OpenAI, Anthropic. Right now, we are using OpenAI, and this is quite fast too, in a custom pipeline as well. This is the high level architecture. This is the tech architecture that we are following. It's just the front end is in React, and back end we are using GraphQL mutation for Ask Glyphic, and we are using GraphQL subscription only to push the messages from backend to front end, and then AI layer we are using Diffie, and and inside Diffie we are using OpenAI as a LLM provider. So the request flow is simple. It's like user will ask question in front end, then front end triggers backend, and then in the backend we are calling Diffie APIs. The API is chat slash chat messages, and then once we get the response from Diffie, we push that to front end. Is the simple flow. And what we have done so far is we added this we made the bot as a multi-turn conversation, so it can remember the conversation and it has all the context of the user in the platform. And we reduced the latency from 25 to 40 second to 10 second. Right now the latency is 10 second. The aim is to go to 2 to 5, but right now it's 10 second only. And we have conversation history per user. It's not per org. If two three different folks are asking question on their Glyphic platform, so for each user the history is different, and they'll see their different conversation in the Diffie. And we are also taking the feedback on answers. This is something Diffie provides. So for each message you can take the feedback. And this also has we also answer the page aware queries, like if someone asks why my flow is not working, so it can actually go to notification and check, okay, if something is there in the notification, or other sort of things like user is not active, their status is not valid. So these kind of questions the bot can answer. So we combined simple rag with org specific data to get the relevant responses. And the data and privacy side, the conversation is scoped to per user. So only I can see my conversation. In the not all members in the org can have access to the conversation that I am having. And the conversation metadata is stored in Glyphic DB, but the conversation history and everything is stored on Diffie is end. And yeah, and only authenticated user can ask the question. Yeah, that's it. Um, yeah, Akansha can share you
Yeah,
the example.
yeah. So we've tried to bring the chatbot within the Glyphic platform. We have one Discord bot right now where users come in and ask their questions, but the problem with that is that it takes like 25 to 40 seconds to answer a query, and it's not conversational. So you can only ask one question and the Glyphic bot answers that. So what we've tried to do is bring Ask Glyphic within the platform here. And as Amisha mentioned, we have two routes for it. One is for basic how-to queries, which is answered through the documentation, and the other one is more of a debugging query, which is answered from the organization's data. So let's say my Google Sheets are not syncing, so I go there and I just ask, why are my sheets not syncing? Yeah. So it went through the data and it found out that these sheets have some errors. So if you see in the sheets page, there are some failed sheets. There is failure reason, but that's not very clear. So the real reason was inside the DB and the notifications. So it combined both of those datas, and it is just giving like an overview of why these sheets are not syncing and how, like, what can you do to fix the error. So this was the first route. It is also able to answer uh, the how-to queries. Like if I want to ask how do I send bulk messages to users, this goes through the second route. And yeah, so it gives the user step-by-step instructions on what to do. Like go to the flow screen, create the flow, publish the flow, and create a collection and go to triggers and create a new trigger. So yeah, this is what we've done till now. The next steps are so we've covered certain tables right now, like notification sheets, contacts. We'll add in more tables so that the bot is able to answer more questions. So we will increase the scope slowly. So yeah, that is something, and we'll also look at if we can reduce the latency from, like, right now it's 10 to 15 seconds, if we can reduce it further. And yeah, also there's an option to just record your feedback. So all of this data resides within Diffie. So if, let's say, tomorrow I have to do analysis on how well my bot is performing, I can just go and check in site Diffie. I can show you the stuff. I'm not logged in, but yeah, all of this data resides within Glific. Sorry, within Diffie. So yeah, that's it. I'll pause for questions.
Thank you so much, Amisha and Akansha. Any questions from anyone?
I have a question, two questions. So this is really cool. Can you talk about, one is I'd like to hear more about how you reduce latency. Yeah, that's the first question. I'll ask the second question after.
So like how earlier we were just using OpenAI APIs and the prompt and documentation that we uploaded, all of that was taking a lot of tokens. With Diffie, what we've done is we've chunked the documentation into some parts, and we have multiple LLMs in the Diffie flow. So, like whenever the user asks a question, we get this snapshot of the user of the organization data and keep that with us, and we query that to find out the answer. And in most cases, the answer is found in the latest snapshot. If not, then it goes further and queries the database again. So with steps like that, we've tried to reduce the latency.
I see. And the second question then is, what do you think it would take to go from providing suggested answers to a user to actually getting the bot to do it? You know what I mean? So instead of saying go to this page and do this and do that, what if the bot just, do you think it would be possible for it to just do it?
Or it can
Yeah,
be
go on.
possible, but that's not the, I mean, there's something we don't want to do.
Oh, okay.
Scope. We don't want to bot to edit anything. We just want bot to just answer what all step they need to do, and user will do themselves. So we didn't explore that part because
I see. Would Diffie make that easy to do? Does Diffie support something like that?
um,
Diffie won't support. It can give us like a summary of what needs to be done, and we
Yeah,
on
okay.
Glific side we can do that. But knowing our like our clients, like our NGOs, we wouldn't want to do that because a lot of sensitive data lies within our DB, so we wouldn't want Diffie or any APIs to make changes to our DB right now
I
or
see.
on the platform. Yeah.
I see. Okay.
but to
Cool.
answer, yeah, it's possible. It's possible to do that as well.
Cool.
So I think we in Avni team we tried it, and for all cases or for bigger configurations, we see so far it is not successful, and for smaller configurations it is successful. I think Himesh can share more during the next presentation.
Cool. Thanks.
I had one question. So are you using the MCP capability within Diffie for your flow for the Glific chatbot?
No, we're not using MCP.
You're just using HTTP nodes for making the data explicit?
Yeah. Yeah.
Any other questions, anyone? Cool. Thank you so much, Amisha and Akansha. We can move to Samanvay's presentation by Himesh and Mahalakshmi.
No, the screen is visible. Guys,
Yes, we can see your screen.
Hi all. So this is mostly going to be sort of explanation of what our learnings have been in the past a month and a half. Mostly a rant on the struggles we've been through. Bear with me. Yeah. So to get started, what's the problem which we wanted to solve with Avni? Avni is used for field data collection, and usually a program manager and so on would like to set up Avni to use for their program, right? So when the requirement comes in, there are three big major personas. One, a business analyst who uh, gets the requirements from the program manager, what sort of forms are required, what configurations to enable, and so on. And once that is set, it is then handed over to an implementer who configures Avni based on those requirements and verifies that things are working, a dev test, and then it's handed over to a valid QA person who then validates that the business requirements are met through those app configurations. So the complexity of Avni is fair bit because these programs usually run are already running on ground, and they have multiple sub-programs within them. So to give you an example, I will okay, the video is supposed to load. Okay, I no.
So Imesh, I think your voice got cut. I will call him, and I think there is some issue, network issue in the office.
Oh, sorry. Is my screen not visible now?
No, not it.
Okay.
Yeah, yes, now visible.
Okay. Okay. So I think I can't share it there. Oh, I can't play a video while sharing the screen, is it?
Yeah. Like you can share it in a, I think, in a short, like not in the slideshow, but in the normal mode.
Okay.
Yeah, in the drive, I think that's better.
Okay, fine. Anyways. Um, yeah, so this is the sort of configuration sped up which they set up in Agni. You have to create multiple forms which has 11 questions, around 20 odd questions in each form. This is a mid-sized form wherein there are multiple fields, weight, height. This is related to some health record for a beneficiary if you are trying to get some concepts, you have to create multiple report cards and rules which we have to set up. So just a fair representation of the complexity which is involved within the app. Right. Yeah, it's playing here now. So that was the problem which we had. There are three personas: business analyst, an implementer, and a QA, who sort of is required for you to set it up. For self-service use cases, it would be a tall ask for people to do this whole thing by themselves. And currently, our team does it. We leverage AI to do this through the IDEs. But then there are variables there: who the developer is, how much of effort they use, what models they apply, and so on. Sometimes they are not using all the in-depth prompts and so on. So the output can vary. Our aim was to sort of take away variation or variability in quality of configuration and have a in-chat experience, in-app chat experience for people to be able to set up Avni by themselves. It could be internal team members or external program managers. And to do this with almost like 90% fixed outcomes is what we wanted to do. It could be chat based, it could be based on some PDF files or CSV files or some forms uploaded to the system. And based on that, set up the Avni configuration. The end goal is that you reduce the barriers to entry and also set up the forms quickly. So moving on to the next, so this is the overall architecture which we have for doing this. So the user on top starts with interacting with the application via chat. So we use Diffie for this. So in the Diffie orchestration layer, we have a agentic workflow which receives the user inputs, processes them, goes through certain nodes, traversals, makes thinks about what has to be done, and when it has to execute the operations, we don't we take out the variability by asking it to make use of certain function tool calling. So we have built tools on top of our Avni application which are the means for the Diffie brains to get the work done. Okay, so most of the time we want Diffie to be invoking these API endpoints in order to get the work done. These endpoints could be related to parsing a CSV file, creating a specific spec document based on some chat, and then converting that spec document to Avni form configuration. And if you want to validate whether the spec document and the form configuration are matching, so then use the functions for them as well. So these are the function tool calls which we have built a layer below that. And then finally, once the tool calls are done, we also have endpoints to upload the bundle onto the Avni system and affect the change, right? This is the overall architecture which we wanted to we have envisioned. And the problem initially seems like it is mostly AI, but what we have found in experience is it's we leaving to AI adds a lot of variability, randomness to the equation, and to take it all out, we use deterministic functions, deterministic endpoints in order to solve them. So it's mostly deterministic, and wherever there are gaps, we use agentic thinking to plug them. So we'll just do a quick demo of what we have built so far now. This is a pretty long video. It's 11 minutes. So a small organization which we are trying to set up. I hope you can see my screen now. So when you are trying to set it up, so you, in this case, I'm uploading a spec document, which is of specific format. It has a standard format spec which says these are the forms I want, and within the forms what are the fields I want, what type of fields they are. So these specifications are there. There are about 20 sheets within those forms. It can be multiple, it can be 2, it can be 3. So right now this organization is empty. That is what I'm showing here, that there's no configuration done. And then it kicks off the flow. And this flow goes through various agents. So we have a multi-agent, multi-sub-agentic workflow within Glific. So it goes through the various steps, converting, parsing the files and generating a spec, then converting that spec to configuration, then validating that configuration, and finally applying that on the system. If there are any ambiguities during the scoping stage, it will also throw, it will interrupt itself and ask a user for feedback as to how to go about it. So based on the input, it then resolves those ambiguities and then moves further. So uh, initial flow of taking scoping documents as input and generating the bundle configuration forms and so on is already working. So I'll just fast forward because not much happens for a long time. So I think till the yeah, I'm just showing the various steps which we have gone through here. I'll just pause it here. So we have gone through uploading the files and then parsing the SRS file and doing spec agent is the one which comes up with the scoping document. So we use a spec format. So that will be our source of truth. That is what helps bring together the non standard input from the user and the app configuration on the other end. So it is held together, tied together by means of a spec YAML format file. So we are generating that here, and then I think it's trying to go forward. So it has said that it has come up with a spec, and this is what it looks like. There are some subject types, address levels, and so on. So and it's just asking, does this look good? Shall I proceed? The bundle has not been uploaded. It's also generated the configuration, and it's just asking, should I go ahead and upload the bundle? So I'm saying upload the bundle next. So once I specify that, the flow, it again goes through various steps. Bundle config agent comes in. It does one other sweep of the bundle configuration, verifies that things are looking good. And yeah, so it has already applied the bundle. As part of that, it also uploaded the bundle. So then I am now seeing that there are forms getting created. So I think I should go back. Yeah, so there are these forms which have gotten created, and the AI still has not come back with a response, but on the back end, it has sort of started applying these changes. So if there are errors, it also handles that after uploading a bundle or during the bundle upload. If there are errors, it tries to resolve it for itself and then does a fix. So that is also there. But for that, it would have usually it tries to catch as many things as possible before that. But during bundle upload, there might still be errors. So yeah. So once so I'm just showing to what the configuration got generated, what the configuration is that's gotten generated. And then finally, it comes back with a response saying, I think I show it in the end as well. Yeah, your bundle has been uploaded to Avni successfully, and these were the things which were created, and you can go out and verify the things. So this is a plain vanilla flow for a fresh start, wherein you have nothing on the app, and you upload the scoping document configuration, and it comes up with some forms based on the inputs which we have specified, right? So assessment and distribution, and so on. So this is what it is. Um,
Just to add, so after this, since the configuration is done, someone, Avni implementer or a client can just create a user, open Avni app, log in, and then start filling the forms. So that is the final outcome. Basically, it would be easy for anyone to start using the Avni app. Yeah, go ahead, Imesh. Thank you.
Yeah, so now we'll get to the lessons part, or probably hard-earned lessons. Where to put the LLMs? Um, I think there is one slide. Yeah, this is the sort of flow which we have built. A snippet, it's not the whole flow as well, but this is just a block of an agentic loop with the flow which we have. There are multiple sub-agents and so on. And if you were to think, right, all the work is done by these agents. Actually, yeah, not mostly the work is done by the tools within them. So this yellow lines which are shown are the number of tools that have been provided for these agentic nodes in order to perform their work. So they use these tools in order to do their work. Yeah, it's a combination of the agent and the tool in order to get the work done. Okay, so yeah, where to put the LLM. So we usually went deterministic. Whenever we let LLM do most of the heavy lifting, it eats up a lot of tokens. So cost is gets too high. It variation There's variance in the output which it generates. So reproducibility thing, repeated use thing doesn't get satisfied. And yeah, if you can write a configuration for it, you can write code for doing a step, then very well use that as a tool, build that as a tool for that LLM agent, and don't let LLM have to think about it and write it for itself, right, every time. So that is there. And then validations, if you want to validate something, you know what is the expectation. So break those into small chunks and write validators for those as well. So we have used deterministic capabilities tools for parsing the files, for validation, for state management variables to keep track of those things, and so on. So all of that is done with variables and code, yeah, regular code. When do we use LLM? LLMs are used, the AI brains come in when you have to talk with the user, interpret what his responses are. That is when we do that. And when we have to plug in the gaps, tooling call has to know if I say ignore form or create a basic form, then it has to interpret that what it would apply in this intent. So if this is a program for which he's saying that, then it should be a specific type of form. If it is a subject, then it should be a different type of form. You configure it. So those things have to be interpreted. Because map the user input to the domain terminology or classification. So for that, we use the AI. And yeah, even to handle variation in input, right, language and so on, we would use AI for that. So classification, dialogue, some generation of responses and auditing, we use AI for it. And letting AI handle the orchestration was the biggest problem. I will talk more about this at the end slide, but orchestrating across these agents is a huge pain. And we have seen that deterministic flow is something which works better for us or work better for a certain extent. But using LLMs, it was very difficult to do prompt handling and get the thing to behave the same way, the way it expected, because there is ambiguity in the requirement of the user. It depends on the current state of the system and what the user asks. So based on that, things have to vary. So yeah, that is one of the major challenges which we'll talk about later. Yeah, so the lesson from our this thing here is if you can write a contract, if you can write it in regular code, then do it. If not, then you'll have to use agents for it. So yeah, so this is the spec. This is again a snippet of our spec configuration. This is what holds the two ends together: the ambiguous user input on one end and the Avni app configuration on the other end. So it is bound based on what this is. So AI uses it converts the ambiguous inputs into this format, and then this is internally converted into specific UUID, specific bundle app configurations, and these what is it? So it does it with this. So we do spec-driven development as part of this flow. So the second lesson which we have is how to shape the agents. Uh, first time we started, we weren't actually using agentic nodes. So Maha suggested we should start using agentic nodes, and then we switched to one big agent which had all the tools, and we gave it 1 million context opus, and we tried to do it. But we used to run out of tokens. A context window would get exceeded, and so on. So that's when so we already knew, like Vinay, our mentor, had already suggested that we should have we use agentic patterns, design patterns, and use them. But we nevertheless gave a try, sort of like we can do it with the IDE. Why can't we do it here? So that was what I tried out with, but it failed. So then we broke it down into the usual plan, plan, execute, verify design pattern which we have with agentic AI. So that is what we have built. So the spec agent is sort of the planner. Then the bundle config agent. There are multiple synthesizer and patcher agents bundled together, which do different tasks. Like one is for generating forms, another is for generating special complex rules, another is for generating reports. So for specific specialization, we have a specific synthesizer patcher. And finally, there is a overall validator or inspector, which verifies that based on the spec is the configuration generated and so on. And there's also a classifier and orchestrator, which we have tried out as well. So we have multiple different agent nodes, archetypes, which have been used in the flow. And these provide the benefit that your agent has memory only for the specific task, and it is able to. We were earlier running out of context window, the 200K context window within a few turns, but now we are able to even hit 20 turns, more than that, by using a combination of um, specialized tools and yeah, sub agents. It uses a specific agent, it does its job better, and even edits. It can do specific edits. You don't regenerate the whole content. You give it an ability to do specific changes. It changes only a chunk of it and not the whole file, right? So specialists can do that. So we have shaped our agents in this manner. Small brain, a clear job, and I'll ask it to always do edits in chunks. Please do let me know if you have any questions. We can take them later. Yeah. So this was the example which I've already shown. The various agents, the spec agent, planner or configurator, and then the bundle config agent, tools agent, and reports agent. These are the synthesizers or patchers. And then there is an inspector agent. This is again the inspector. We had put in an orchestrator agent here. It didn't work so well. So it's a regular classifier, a deterministic classifier, which I have here now. But yeah, these are just some. Third lesson, how to design the tools. So the three layers, as I said, the initial Diffie layer, then the tools, and finally the Avni backend. So the tools layer is sort of what we say is something which we will probably keep reusing no matter where we go. I'll get there later, but in general, the tools layer has been built so that you don't have to lug things around. So so our problem is long horizon open-ended task. You are trying to set up the configuration, which can be a huge chunk, which is done only at the beginning of a program setup. It's not like there are 100 or 200 users who are coming in and trying to use Avni and set up Avni at the same time. So we are expecting one or two users external from external outside the organization who might be using the app configurator at a given time. And once their app is set up, they pretty much don't meddle with it. They might come back a few months later to tweak a form here and there, add a new form, but that's pretty much it. Internal team might use it, but yeah, our internal team might be more heavy usage of our app. Um, but yeah, so in general, when they are using, when they are designing these tools, we sort of learned these lessons bit by bit. The first thing was sectional retrieval. So earlier we used to give the whole, so say if there's a spec, give the whole spec as is to the LLM, and it used to eat up all the tokens. So now we give the spec based on sections. So you have API endpoint. So I can show you here what I mean by that. So if you see a spec section here, so we have ability to specify what section information has to be fetched as part of this get or put modify end call. So both of them are the modify update as well as the fetch are filtered based on the subsection which we want to get information about or update. So this is something which we have seen to have a huge impact on um, what we on the token context window not getting bloated, right? That is one. And response truncation. So if we are asking it for some rules or something, or some other JSON file or some knowledge retrieval, giving a whole huge bunch of information. We have embedded knowledge retrieval, but yeah, in some instances we are again fetching some information. So we want to truncate it as well and not give it the whole thing. So we are reducing it, keeping it low to like 8,000 characters and so on. So that is something which we use. And then surgical edits, as I said, retrieval as well as modifications are sectional or surgical. You specify what has to be specifically changed, and you only act on that. You don't modify the whole file, regenerate the whole file every time. That is one. And then stateless. So within the tools, we don't maintain any state. The tools can themselves be used to modify the state, the app configuration, the data in general. But given input, it is supposed to generate the same output uh, uh, and so on. So within the tool, there is no state. It will not say, okay, this is already done, or it will not change behavior based on number of times you execute it. Then yeah, give it handles and not payloads. So what I mean by this is, so those XLS scoping documents which you saw, they can be around 20 KB files, right? If you were to push this to an LLM, then that itself takes out the whole context. So we don't do that. What we are actually doing is we are using HTTP nodes and pushing these files onto our workspace or the sandbox area, and then we give it a handle saying this is the handle you can use to move these files around, to then use you say, okay, this is your handle, uh, and do what you want to do with it. And then the next time the workflow wants to parse those files, so it says, okay, this is the file set which we have here, parser, go and parse this file and give me the output. And it doesn't say give me the output, write the output to another file, right? So it returns a handle to that output file as well. So we don't lug around the whole thing on the agentic layer. We handle it at the tool layer, the big payloads, and then have defensive guards within the tools. So what you produce can also be tested as part of that same call itself, so that you don't have to, you don't let LLM have to validate it later. You don't let the problem fester for long. So This helped us, as I said, we could go from 5 to 6 turns to about 20 odd turns within those specialized agents by adopting these measures. Yeah, these are the three lessons, major lessons which we had. A lot more, but for now, this is what I will share. So yeah, when designing tools, design the tool for the agent, and yeah, follow some of the practices. Final slide. Yeah, this is already we saw this. So this is the final thing about what we have, what our final this thing is takeaways are so far. Um, so far, we're saying that when we use anything around LangChain, LangGraph, an agentic workflow, it's very difficult to solve the problem where it's open-ended, right? So if someone has set up Avni today and comes back a month later and wants to get started and handle some form changes, it is difficult if you sort of have to create a form while not having any impact on the existing configuration. Whereas the same flow also has to handle a newcomer, a person who is just starting off with his app configuration journey to handle that flow as well. And someone else who's just looking at doing administration tasks around creating users, configuring their privileges, and so on. So to do anything which is very complex, open-ended all the time, and can to do that with an agentic workflow, building the harness around it by ourselves was a huge challenge. We were not able to crack it, and based on our mentors' input last week, as well from our co-founders, we are planning to move to cloud managed agents. Yeah, so that is one thing. That is a major outcome from our 1.5 months of effort. And yeah, but the tools can be reused. Our knowledge base and the rest of the things can be reused. So we will continue to enhance our tools, enhance our spec configurations and our generators to build it further. And then use cloud managed agents to in order to give it ability to handle open-ended long-running tasks with various flows. And we'll also build in some production safety. So the overall design, there are some security flaws within our Diffie workflow design. So those should go away if we were to choose an alternative framework. And yeah, we also need to do some benchmark testing and so on within for our capabilities. And finally, we'll also build on converting unstructured multimodal content as input from the users and build a spec document out of it. Because once we have the spec document, then rest of the game is the same. Generating bundle configuration reports, rules is already would have already been solved. So this is the second phase of work which we were planning to do. Yeah, shortcomings of Diffie. This few of them were already known. Few of them we got to know much more intimately during the few weeks. So doc extraction nodes, which within Diffie are not so strong. They miss out a lot of content. They are not reliable. Agent nodes cannot use perishable tokens. If you have short-lived 1 hour, 1 month, 1 week, whatever tokens, if your conversation lasts longer than that, then it will break. You cannot stitch together different workflows, and the prompt length is also limited. We sometimes have prompts running to 20,000 characters, but Diffie does not support that. And yeah, we are used to code-based capability, like able to swap in, swap out code, test it, build it. So that is not easy when you are using Diffie flows in general. So this are the shortcomings which we have with Diffie. The good part is, as you know, it gives you those what Glific team has already conveyed. It gives you inbuilt user conversation management. It is easy for non-technical people to use knowledge base, flows, time to market, and integration, and LLM agnostic, vendor agnostic, and all of those capabilities, which are good. So if you have a need for a simple chat bot, or if you need something to do with a specific flow, which you want a simple flow to be performed, then Diffie is your, I would say Diffie does it very well. But if you have something which is open-ended and long-running and complex, then it might not be your choice of field. So that is it. And yeah, LLM, we also, yeah, IDEs makes it using Cloud Code agent and stuff. It seems that AI is so easy, but then once you get to do this, it is sweet. Devil is in the details. So that's it from our end. Open to some questions.
I think Ashwin had a question. He's raised his hand.
Oh, sorry.
Yeah, hi, Himesh. It was a very beautiful session and a lot of insights from your learning. Really interesting to see how you have layered different structures and had your learnings on those. Really great. I just have two questions, one on the architecture and the other on the performance. On the
Okay.
architecture, I think you mentioned that you replaced your non-deterministic layer or the orchestration layer into a deterministic layer. I just wanted to understand on the agents level. You have multiple agents, right? So on the agents level, are every agent again deterministic or non-deterministic by itself? Because they have multiple tools. Do you again have a deterministic layer for every agent to, call whatever tools has to be called depending on the context of the user, or it is non-deterministic at that level? Is my question clear?
So I'll try to answer it, and then we can see if you need further clarification.
Yes, please.
Yeah, so the orchestrator layer which we had. So when I meant an LLM agent, so we had a huge prompt which said which said based on what was the previous agent, we have conversation variables which say what was the agent, what is the current agent, what is the state of the flow, and so on. So based on certain variables which we have some flags. So imagine there's as flags which says what is the mode we are working in, what is the current agent, what is the current intention, and so on. What is the app state and so on. So you have put several variables, flags, which we have maintained. And once a flow comes back to the orchestrator, it was supposed to, based on the user response and the flag state, determine which agent it has to go to, right? So that is what we try to build. But it used to break even for the regular vanilla flow, which we are talking about. It used to break. It was not able to handle it. With a lot of prompt hardening and so on, it still had a lot of trouble because there is inherently within our flow, there is an expectation that if there is a change in the base layer somewhere, then that change has to be um, uh, s- uh, uh, bubbled up to a top layer change. It might also need a rules change and so on. So you will have to surface that error all the way to the top. So orchestrator is not able to manage it. It might just say go and change in the spec, but it might not be able to say then go and change it in the forms and then move it on. It might get lost in one of the layers and not complete the whole configuration. So that was the challenge which we had. So instead of that, what we now are doing in the flow is give it a deterministic flow. So just say if this is a change and it seems to be a spec change, then go to spec change and mandatorily go through rest of the layers based on what sort of a spec change are there. A few of them might be skipped, but always follow a linear path or like go in a specific direction. So that is what we have ended up using, right? And the
Okay,
second
great.
part, yeah, the second thing within the agents. So the tool calls which we have, I think we showed here the tool calls which we have. So these are deterministic tool calls. Anything outside this is for the LLM to interpret. It chooses which tool to use when. We don't tell it. We give it some basic instructions like see if the bundle already exists. If it is not, then invoke generate bundle. Okay, so this is the initial setup phase for a specific agent, okay, the bundle agent. So once that is done, it is then supposed to say, okay, do based on the specs, see what has to be changed in then do make the change. So these are the instructions we give, and then how many times it has to go and verify that the change has done. Those things we do not control. We give it a rough outline as to how it has to behave and what sort of sequence the tools might be used in, but LLM makes the decision its decision on what the actual ordering of the tool. It might also given it a tool to do free greenfield changes, execute configurations, create a whole file for itself. So those tools are also available. So it chooses when which tool to use when. If it fails, it chooses to make some corrections using some other tool as well. So all that it decides by itself.
Great, great, great. My second question is when you changed your orchestration layer to be a deterministic layer, in terms of both performance and also latency, like also the quality of the changes of your, what were the impact that you saw?
So actually, that is a problem which is not solved, to be honest. And that is why we are moving away. Orchestration with the deterministic approach works, okay, but it is very hard coded. It cannot handle what we are thinking about. Like if I have set up a configuration and I randomly say, do this user, set up some user group privileges for this user, and or I say change. Create a whole new form, and so on. It was getting lost even with in the deterministic flow. It was sometimes not affecting that change, whereas with the LLM flow it used to get lost in one of the nodes and get stuck there. So neither the deterministic nor the LLM based orchestration work. If you are saying a user might say one thing at once and then change to a whole different thing, so it is not working. The performance gains. So if the thing is not working, so I'm not going to comment on the performance gains. It's not like in the cases where it works, the deterministic is obviously faster. The LLM uses some tokens and some few seconds in order to do the routing, but neither of them have worked for us.
Got it, nice. Thank you so much.